Assalamu alaikum. Welcome to lecture 8 of CS 5316 on natural language processing. Today, we will continue our discussion on machine learning for NLP. This, for some, would be a recap of what they have studied already in a course on machine learning before this class. But a refresher, I guess, is always important since machine learning and AI is widely used in different applications. Multiple reminders, multiple refreshers would only solidify your understanding. So we had started about logistic regression last time. We will continue with that discussion, talking about simple logistic regression, then multinomial logistic regression. We will also talk about the loss function that is typically used for these two types of logistic functions. We will briefly talk about learning the parameters. We won't go into the details and the algorithms. And then after that, we will start talking about neural networks, feed-forward neural networks, which are a simple extension of logistic regression. Uh, so that is basically the agenda for today. There will be a bit of notation today, so I hope you keep track with me. And if you have any questions, you can stop me and ask. So, of course, we will do a small example as well. You can say a dry run of logistic regression, the equations, so that everyone understands what's going on. So that's the agenda for today. Any questions? All right. So are there any questions? So you will have a quiz on Monday, the following class on Tuesday, the Monday, sorry, next Monday at the end of class. So the format will be similar to the one that you saw in quiz 1. It will cover everything till today's lecture. All right. So we looked at a linear model. So Z is equal to W1 X1 plus W2 X2 plus dot 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 W M X M plus B. So 1, 2, 3, and M, these you can consider to be subscripts. Okay? And so this is a linear model in the input features X. So X1 to XM is the feature. You can represent that as a vector X. So this is X1 to XM. So generally vectors would be bolded. Okay. And of course, similarly, you have the vector of parameter W, which is W1 to WM. Okay. So when I will, for convenience, I might omit bolding things, but you should understand from the context what is being represented, either one element of a vector or the complete vector. Okay. So B is also a parameter, but this is scalar. So sometimes, as I wrote in the last lecture, you can write B as W naught and include it into the vector W. So this is done in some notations and it's sometimes convenient, and you will see this in the book and in many places. So sometimes you write it separately, sometimes you write it as a W naught parameter with the corresponding X naught equal to 1. So B does not have an X in front of it. Okay? So this is a linear model which you probably have studied in linear regression elsewhere. Logistic regression modifies this using a nonlinearity, which is a sigmoid function, and gives you a probability for the output y is equal to 1 given x. X, of course, now is the input vector, okay, is given by the sigmoid of z, okay. And you know what is the sigmoid is? So 1 divided by 1 plus exp, the exponential function, minus z. So note that z is a scalar. So that linear function that I wrote up there will give you a single value. It's a scalar, okay. And that scalar would then be put into this function with the sigmoid function will give you a value between 0 and 1. So p y is equal to 1 given x would give you a value between 0 and 1. So sometimes for notational convenience, y is equal to 1 given x, we can call it as y prime for this particular x to distinguish it from the actual y, which is in the data set. Okay. So this is the output of the logistic regression function. This is a continuous value. So that's why this is called logistic regression. But this regression value, continuous value is between 0 and 1. We saw the sigmoid function, the x function last time. So it squashes between 1 and 0. A value close to 1 would be a probability that the class belongs to 1. Otherwise, the class would belong to 0. Okay. So this, as I said, is called binary logistic regression or simply logistic regression. So I didn't get your question. Let me try to. Yes. So this is a model, a parametric model, which when given x, which is our input, it will give a probability for x belonging to y is equal to 1. And from simple decision theory, since this is a binary classification problem, so when y prime is greater than, or you can even say equal to 0.5, then y is equal to 1. Okay? Otherwise, so otherwise y is equal to 0. So this is our binary classification. Of course, we need to learn this model from data. So that's a learning problem. And learning means that we are learning the parameter w and the parameter b. Or if you have included b in w, the entire vector b, entire vector w. So, but before going to the learning, let me just do a quick example of the feed forward so that everyone understand how this equation works. Let me take a very simple example. Let's say this is for sentiment classification or polarity classification. So you have just two classes, one for positive class, 0 for negative class. And let's say we have an example X. And the feature set, let's say, let me write it as good. X1 is good. And let's say X2 is bad. Let's say X3 is D. And X4 is, let's say, movie, let's say. Of course, this is a small toy example. Usually the feature set would consist of many more features. Usually, if it is words, then it will comprise of the entire vocabulary of the corpus. And for a given X, we will have values. So let's say I'm taking raw counts. Remember, this can be TF, IDF values as well. TF, IDF values will be continuous values, not integer, but you can also use raw counts. So let's say in this particular example, good की count 2 है, ठीक है, and bad का count 0 है, and D का count 3 है, and movie का count 1 है. And let's say this is a positive example in our training data set. Of course, this is a training data set, but let's say I want to use my model to find a label for this. And again, this is hypothetical example. So let's say मेरा W1 जो है, so this is, let's say, W1 is for good. And remember, if you look at the function, that function is predicting the probability of y is equal to 1, which is the probability for positive. So this weight should be generally positive because it should give a better value for a word good. Good is typically used in movie reviews or reviews that are positive. So I'll take a positive value for this, let's say 1.2. Okay? So W2, again for positiveness, 0.5 minus 0.5. Okay? And D usually would be a neutral kind of thing. W3 is for D. So usually I'll take a small value, 0.01. Okay? And movie again is kind of neutral. W4 जो है neutral ही होगा, but again let me take a 0.0 dash 0. Let's say 2 negative. And let's say B मेरे पास, let's say simply taking it as, let's say 0.5, the bias term. So now you can simply use these values with the X value to predict Y. Okay? So let me first compute Z. अच्छा अच्छा So okay, so 1.2 for good, and good का count क्या था? 2 था, plus 0 because of course उसका count bad का 0 है, plus 3 for इसका weight क्या था हमारे पास D का 0. Don't remember, 0.1 था शायद. 0.0 ठीक है, तो 0.01 था. ठीक है. So please help me with these numbers for those who are following closely. Okay, so 0.1 times 3 plus for 4 we have a count of, what is the count for movie? So weight क्या है उसके पहले? minus 0.2. कोई बोल रहा है बट थोड़ा सा ऊंचा बोल लें तो that will be better. Minus 0.2. Okay. So minus 0.2 into movie का count 1 plus 0.5. So we get 2.73. So this is the linear value which is plus. Okay, usually a plus value will be a positive probability because if you look at the S function, the sigmoid function, जब Z plus पे जाता है तो positive probability आती है, Z negative पे जाता है तो negative probability आती है. ठीक है. So let's compute Y prime. So this will be 1 divided by 1 plus EXP minus 2.73. अच्छा ये कैलकुलेट नहीं करता. EXP का किसी को पता है एग्जैक्ट नंबर क्या होता है? 2.7. 2.71 raised to power of exp, right? So the probability that you get is 0.93. So this example has a strong positive probability, and most likely, if you use the decision rule that any probability above 0.5 is class 1 or positive class, so this belongs to class 1. So this uh, doc is positive. ठीक है? So ये feed forward process है. That's how it typically works. You have the learned parameters W and B, and you have the input parameters X. You put it into the model, which is a logistic regression model, 1 over 1 plus exp minus z. Z is, of course, a linear model of X and B. And if you put it in there, it will give you a probability number. And using that probability, you can make a decision. Okay, so this is binary logistic regression. A few words about features before we move on to multi-class logistic regression. So, uh, so the features are, you can use any features that are appropriate for your problem. So it could be words, as we have used before, tokens. It could even be two words in sequence, which is basically called a bigrams, which we'll see in more detail later on. It could also include additional features. Simply ज़रूरी नहीं कि words के base पे features आप ले लें. Maybe you can include features that are not really based on uh, linguistics. They could be based on other things as well. So, for example, emoticons. So, कितने positive emoticons हैं, कितने negative emoticons हैं. So, for example, positive emoticons, negative emoticons. So, you can use all of these features depending on your uh, depending on your classification problem. So in polarity classification problem, these would be helpful. For example, let's say if you're using spam classification, you might want to include features like uh, is the, so for example, a binary feature like is the sender email or domain/domain in block list. ठीक है? ठीक है? So this would be a binary feature. So, and this would be appropriate for spam filtering. And this not is not directly related to linguistic of the content, the language of the content in an email. It's based on the address, the header. तो सारी चीजें आप इंक्लूड कर सकते हैं. रिमेंबर इट्स क्लासिफिकेशन प्रॉब्लम. जो भी आपको इंपॉर्टेंट फीचर लगता है आप डाल सकते हैं. ठीक है? But in general, for many classification problems, if you start simply with words and a vocabulary of those words and take the TF-IDF or any other weighing scheme like raw counts, you will get fairly good results for many applications. So you don't really need to handcraft additional features. ठीक है? Okay, so that's a learning problem. The weight values I assumed were given. So that's a learning problem, and we will come to that very shortly. Now, of course, we won't go into the details of the math there because that's something that you covered in machine learning. But हम अभी discuss करते हैं shortly. So this is just a forward pass. So given a model that has already been learned, meaning that you know all the W's, you know the B, given a new X, you can make a prediction for that X. In this particular example, prediction for class 1 is 0.93, which is a very high probability. So it means that this is with a higher degree of certainty, this example belongs to a positive class. Okay? ठीक है. So generally handcrafted features can be used as relevant for the uh, classification task. ठीक है. Uh, Generally, feature learning is not done or is not part of the uh, logistic regression model. But as we move on to neural network, you will see that feature learning can be incorporated automatically into the learning process, and we do not need to do handcrafting. Of course, handcrafting would help in some cases. हर दफा हम handcrafting से भाग नहीं सकते. So remember, as an AI expert, as a machine learning expert, domain knowledge is very important. So for example, if you want to classify, uh, let's say हम sarcasm detection करना चाह रहे हैं, and you basically give as features the uh, header information in email, or maybe the names of the people that are written in that email, then you will not be able to detect whether there is sarcasm in the email or not. ठीक है. So features appropriate होने चाहिए. You need to know the domain. So domain knowledge कभी भी, even if you have representation learning or feature learning, automatically you need to be expert or fairly knowledgeable in the domain. ठीक है. So we will see feature learning when we go deeper into neural networks. Okay, so let's talk about learning. So where do we get the parameters from? So remember, in the last lecture we said we usually have a training data, a data set, xi, yi, where I is equal to 1 to n. So this is our data set, D. So this data set has samples of our classification problem where we have the x as an input vector, feature vector, and y as the class label already given to us, some representative samples. And we mentioned last time that from a purely probabilistic perspective, we are assuming that this comes IID from unknown distribution of x and y. ठीक है. ठीक है. So data set है, तो इस data set is representative of the problem, and we will use this data set to the uh, fix the uh, parameters. So what do we have? We have y, which is the actual label in data set, and we have y prime as probability output of model. ठीक है. Which of course varies between 0 and 1. And remember, this y prime is for the probability for the class y is equal to 1. So यहाँ वो हमारी original notation 0, 1 would help us. So if y is equal to 1, let's say if y prime is equal to 1, it means that for sure we know that this belongs to class 1. So y prime or y का difference as small as possible होना चाहिए. In that particular case would be 0. If y prime is 0, even and the actual class was 1, then difference would be high. एक 0 है, दूसरा high है. So we will have to somehow build a loss function based on these two things. Remember, y prime में आपके parameters आ रहे हैं सारे. ठीक है. So we have to define a cost function or loss function. ठीक है. Which would quantify the difference between y prime and y given the data set. And since y prime is based on our parameters, we would like to find those parameters that would maximize or minimize the loss. ठीक है. So if I want to write it in layman terms, we want W star, B star. So I'm writing star just for the optimal values. So these are the ones that come from maximizing the loss function. And the loss function is a function of y. Uh, it's a function of y and y, the data set. Okay. And of course, it has what parameters? Okay, parameters वहाँ left पे लिखे हुए हैं, but I can write it here as well, w and b. So let's say we have defined a cost function L, and this cost function has two variables y and y prime, and y prime में आपके पास w और b आ रहे हैं. So given the data set, uh, I'll add the data set here as well, given the data set. Okay? We want to find the best values that minimizes ये min होना चाहिए. Remember loss function है. ठीक है, लॉस फंक्शन को मिनिमाइज करना, नॉट मैक्सिमाइज. यूटिलिटी फंक्शन होता तो मैक्सिमाइज करना था. Okay, a quick question here. How many of you know have have some understanding of maximum likelihood estimation? Although I don't want to go into the details, but आपने maximum likelihood estimation machine learning में पढ़ा होगा. Anyone? Or have you studied MLE somewhere else? Maybe does not ring a bell. अच्छा, that's strange. AI एंड मशीन लर्निंग में तो मेरा ख्याल है कि दिस इज फंडामेंटल. अच्छा. ठीक है. Yeah, that's the whole problem. But I think so the loss function है for binary classification is usually obtained using maximum likelihood estimate. Maximum likelihood estimate. And for this particular case, it actually is equivalent to cross entropy. Uh, so So the whole process, I'll briefly go write some notations here, but I do not assume कि सारे को ये समझ आ जाएगी. For those who can recall it, they probably can understand in a better way. Uh, so what happens is we have a data set and we want to learn the parameter, the distribution y from the data, and data has all those y's. Okay? So usually what happens is probability of y given d. So we basically can write this as probability of d given y, probability of y divided by probability of d. ठीक है? So d is our data set. So we want to estimate the probability, this probability on the left hand side. And if you look at the right hand, of course this is Bayes rule. Bayes rule लगाया हमने. If you look at the right hand side, for a given data set d, since we are maximizing, the denominator does not play a role. सारे optimization के लिए ये same रहेगा. And also we assume that the probability of y, which is a class label, in this case just two classes, 1 and 0, वो दोनों uniform है. ठीक है? So if that is the case, so basically uh, we simply need to maximize a probability of d given y. And this probability of d given y is called the likelihood. Why is it called the likelihood? Because this y, which is our model, can generate the data. Most likely to generate the data. And of course, data में क्या है आपके पास? Various examples हैं, n examples हैं. अब वो n example, if you go back even further, मैंने कहा था ये IID है, right? IID का मतलब ये है कि they are independent. तो ये पूरा product, ये जो एक joint है, so probability of y1, y2, y3, dash dash dash, yn given my model. So there's a bit of variable overloading here. Model was actually, I should have used a different variable. Y prime भी वैसे नहीं है, but खैर आई होप यू अंडरस्टैंड. तो ये है, एंड देन सिंस it is IID, you get a product over all I of probability of yi given y prime. ठीक है. एंड दिस y I की प्रोबेबिलिटी वही है जो हम ऊपर निकाल रहे हैं लॉजिस्टिक रिग्रेशन से. उसके पैरामीटर्स हैं ऑफ कोर्स सारे w and b. तो ये प्रोडक्ट्स है, इसका हम लॉग ले लेते हैं, ये सम बन जाता है. ठीक है. तो सम बन जाता है, तो दैट मेक्स व्हाट इज नोन एज द लॉग लाइक्लीहुड, एंड वी वांट टू मैक्सिमाइज दिस. ठीक है. अगेन मैक्सिमाइजेशन की बात हो रही है, बट इफ यू टेक द नेगेटिव ऑफ दैट you can then minimize it. That becomes a loss function. ठीक है. So a few steps और लगेंगे, you will get to the loss function very easily. So let me write the loss function directly that is used for this, and I'll relate it to you with uh, this discussion that I mentioned. So the loss function for binary is essentially like this. So we have so let me write it first. So y net log of y prime. What is y prime? Is the output of logistic regression. इस नेगेटिव ले लिया, दोनों नेगेटिव हैं. ऊपर हम जब लॉग लेंगे तो सारे प्लस हैं, नेगेटिव ले रहा सब नेगेटिव हो जाएगा. सो 1 माइनस वाई ln 1 माइनस वाई प्राइम. ऊपर जब आप उसका लॉग लेंगे ये सारे सम बन जाएंगे with ln y, and remember this probability that I wrote above for the product is y prime. वही चीज है, बट आगे इसके मैंने ये एक टर्म एक्स्ट्रा लगा दी so that to simplify it. So just let's reason with this. So let's say मेरे पास एक पॉजिटिव एग्जांपल है, उसका y क्या होगा? एनीवन? पॉजिटिव एग्जांपल का y हमने क्या लिया था? ठीक है ना. तो पॉजिटिव एग्जांपल का y हमने 1 लिया था, एंड y प्राइम इज व्हाट? इज द प्रोबेबिलिटी फॉर y इज इक्वल टू 1. दिस इज आउटपुटेड बाय आवर लॉजिस्टिक रिग्रेशन. ठीक है. सो इफ ए पर्टिकुलर एग्जांपल इन आवर डेटा सेट इज पॉजिटिव, ठीक है, so you will have y is equal to 1, and then you will have the probability of y is equal to 1 given by the system, right? And if you look in terms of likelihood, we would like to maximize this as ज़्यादा probability हो. And since we have two terms, second term 0 हो जाएगी, because since this particular example में y 1 था, तो 1 minus 1 second term में 0 हो जाएगी. By the way, ये जो term है ना, ये पूरा summation है over all y is equal to 1 n. So this is now our complete loss function over the entire data set. Data set हमारे पास क्या था? n examples थी. ठीक है. जब एग्जाम्पल हमारी पॉजिटिव होगी पहली टर्म काउंट हो रही होगी, जब हमारी एग्जाम्पल डेटा सेट में नेगेटिव होगी सेकंड टर्म काउंट हो रही होगी, बिकॉज सेकंड टर्म वुड गिव अस अ प्रोबेबिलिटी ऑफ y इज इक्वल टू 0, बिकॉज राइट हैंड साइड में हम 1 माइनस वाई प्राइम ले रहे हैं. And if we had not added the negative, we would have to do the maximization of this. But हमने negative कर दिया, we will doing a minimization. And since this minimization, we call this a loss function. और हमारे parameters कहाँ आ रहे हैं? Y prime में आ रहे हैं. So this is a loss function, the objective function, which we'll have to minimize. And this is also called a cross entropy. So Anyone knows why this is called entropy or cross entropy? कोई इसके साथ रिजेम्बलेंस नजर आ रही है एंट्रोपी के साथ? सो एंट्रोपी फॉर वन रैंडम वेरिएबल क्या होता है? लेट्स से कोई रैंडम वेरिएबल, उसकी प्रोबेबिलिटी लेट्स से पी है, सो पी लिया, नेचुरल प्रोबेबिलिटी ऑफ पी, दिस इज फॉर वन रैंडम वेरिएबल। एंट्रोपी ये होती है ना। सो क्रॉस एंट्रोपी बिटवीन टू वेरिएबल्स, लेट्स से क्यू, एल एंड पी, so this is cross entropy. So the formula that we have obtained using maximum likelihood and taking the log and taking the negative is almost identical to cross entropy. हमारे पास log of y prime है, and then we have simply y on the left hand side. So that's why this is called cross entropy, entropy between two variables. One is y, the other is y prime. And entropy आपको पता है कि smaller is better. So that's why we are minimizing. ठीक है ना? Zero means that it is homogeneous. These two variables are homogeneous. जो y की वैल्यू होगी वही y प्राइम की वैल्यू होगी. ठीक है? Homogeneity would means a entropy of zero, and we have come to the same formulation by using the maximum likelihood approach, maximizing our probability over the data, taking the log, taking the negative, and minimizing it would give us the cross entropy. ठीक है? तो ये हमारा ऑब्जेक्टिव फंक्शन है फॉर okay, any questions so far? So please review your machine learning after this. But of course, but ये वाली हमारी, it's not like we will be testing you on these probabilities and these formulations, but formulations आपको पता होनी चाहिए. uh, हम exactly ये टेस्ट नहीं करेंगे, आपको फीड फॉरवर्ड आपका टेस्ट करेंगे, यूज टेस्ट करेंगे, बट to derive these we will not test in this course. But since AI and ML is so common today, I guess मल्टीपल रिपीटिशन से आप लोगों को याद हो जानी चाहिए. It's so universal nowadays. Cross entropy, softmax, and so on. All these functions you should know by heart and how they are derived. Okay, any questions? I'll stop here for a few seconds. So our objective function is basically this, which is a loss function. And this function is a function of W and B. So you minimize this objective function and find, so we find W star, B star by minimizing L. Okay? So it's solving an objective function optimization problem. Okay? And for logistic regression, the optimization problem is convex. Okay? So anyone can comment on this? Convex का क्या फायदा होगा हमको? Unimodal and convex. ठीक है. So machine learning सबको भूली हुई है लगता है. ठीक है. ठीक है. So convex means that you will have just one minima, and that means yes. So L is a convex function. The loss function is convex. So if your convex function, if your loss function is convex, and as I said, also unimodal, meaning that any minima of that function would also be a global minima. ठीक है. So minima, any minimum single minimum, so which is a, ठीक है. बट दिस इज ओनली ट्रू फॉर लॉजिस्टिक रिग्रेशन. जब आप मल्टीपल लेयर्स ऐड कर देंगे एक न्यूरल नेटवर्क में, आगे जाके हम देखेंगे, तो ये नॉन कॉन्वेक्स हो जाएगी. देन यू मे हैव मैनी लोकल मिनिमास. ऑलराइट, अब इसको निकालते किस तरह है और हाउ डू यू सॉल्व इट? दे आर, सिंस दिस इज कॉन्वेक्स, तो यू कैन डू इट विद वेरियस मेथड्स. जिन्होंने ऑप्टिमाइजेशन पढ़ी हुई है, न्यूटन्स मेथड से भी इसको सॉल्व कर सकते हैं, विच यूज द सेकंड डेरिवेटिव, and it will give you a solution in if only a few steps. For example, इसमें जो टेक्निक यूज होती है for logistic regression is often called iterative reweight least squares. So we won't go into this. जब when I used to teach machine learning, ये हम डिटेल में डिस्कस करते थे. But so stochastic gradient descent is, this method uses the first gradient. And this is the method that is used most commonly nowadays as well as for neural networks. Gradient. ठीक है. सो वेरी ब्रीफली अगेन, ये भी हमारा इसका पार्ट नहीं है इन डिटेल, बट वेरी ब्रीफली यू शुड नो. सो रिमेंबर, हमारा पैरामीटर W थे और B थे. सो लेट मी जस्ट यूज W हेयर. सो इट्स एन आइटरेटिव प्रोसेस. सो लेट्स से वन, लेट मी राइट वन स्टेप. W new is equal to W old in the old step minus, there is a scalar parameter which we call eta, multiplied by the gradient of L. ठीक है. Very simple iterative process, one step to the next process. Eta, as I said, is greater than 0 always. This is learning parameter, learning rate parameter. By the way, this would be a hyperparameter because जो models के parameters हैं, those are called parameters. Additional parameters are often called hyperparameters. ठीक है. ठीक है. And gradient L is the derivative, or usually the partial derivative of L with respect to W. ठीक है. तो ग्रेडियंट आपको पॉजिटिव डायरेक्शन में पॉइंट करता है. से डायरेक्शन, ग्रेडियंट इज अ डायरेक्शन, इज अ वेक्टर डायरेक्शन. So we have taken a negative, so we have taken the negative of it, ठीक है, and then we have moved in that direction by some scalar value eta, and we do it repeatedly until there is no change in W new after a W old, or the change is very small, meaning that we have reached a trough, a bottom or pit in our loss function. एक बीच में जब हॉरिजॉन्टल पहुंच जाएगा तो ग्रेडियंट जीरो हो जाएगा. ग्रेडियंट जब जीरो हो जाएगा तो देन W न्यू W ओल्ड चेंज नहीं होगा, because gradient would be zero. ठीक है. So that's the process, iterative process. Eta, of course, you have to update with each step, and there are various ways of doing that. It's not, doesn't, it's usually a fixed eta throughout the iterations. Usually नहीं use करते हम. It's usually adaptive. ठीक है. So there are various ways of adapting this, and in your implementation, you will find various names like, for example, Adam, for example, with momentum as well, adaptive with momentum. So momentum is another way of making sure your optimization runs faster. तो इस तरह के कई वेरिएशंस आपको इम्प्लीमेंटेशन में मिल जाएंगे. यूजली एडम वर्क्स वेल इन प्रैक्टिस. ठीक है. एंड अदर्स ऑप्टिमाइजेशन स्ट्रेटजीज. ठीक है. ठीक है. सो एनी क्वेश्चंस हियर सो फार? लॉस फंक्शन समझ आ गया? Because loss function is used almost everywhere, almost universal. Very few other application would have a different loss function. Loss function cross entropy ही most likely बनता है, and it's a function that we want to minimize, and its minima at the point at which it reaches a minima, those are the parameters that we want. But that would minimize uh, our cost, you can say, and also maximize our likelihood to the data. All right, very quickly, let's talk about multinomial logistic regression. So far, we have talked about logistic regression with just two classification variables or two class labels. So in general, you can have multi-class classification problem. So for example, even for sentiment classification, you can think of, for example, e.g. positive, negative, and neutral as three labels. Okay. For example, cyber crime detection. Cyber crime में detection में your labels could be, for example, hate, offensive, offensive, uh, I don't know, cyberbullying, and cyber terrorist, terrorism, etc. So there could be various more than two classes. So given a tweet or a message or whatever, we want to determine whether it is hateful in nature, offensive in nature, it is exhibiting bullying behavior, or it is exhibiting a terrorist information. ठीक है. So multi-class classification problem. Of course, न्यूट्रल भी होगा आपके पास. So none of the above. ठीक है. So in general, we can say that we have k greater than two classes. So this will be a multi-class classification problem. So more than two classes. ठीक है. So how would we modify our logistic regression? So in this case, the notation for the data set of course, as you know, x is a vector of inputs. For multi-class classification, we consider the y outputs to also be a vector of size capital K. ठीक है. Again, this is notations, because this notation will relatively help us our later calculations to be easier. So this is basically y is a vector of size K. ठीक है. And it is one of K encoding. This is sometimes also called one hot encoding. Although ये one hot encoding का लफ्ज हम later on ज़्यादा use करेंगे. but the same encoding. What is the idea here? Let's say हमारे पास 5 classes हैं, k is equal to 5 है. So let's say you have a vector y is equal to 1, 0, 0, 0, 0. So this basically is class 1. Because पहली पोजीशन पे 1 था, बाकी सारी पोजीशन पे 0 थे. Similarly, another 0, 0, 1, 0, 0. So this would be class 3. इस तरह हम different classes denote कर रहे हैं. So y is not a scalar now, y is a vector. But it's a one hot encoding vector with just one in the entire vector, and the position where that one is tells us which class it is. ठीक है. Any questions? So हमने अपने मल्टी क्लास क्लासिफिकेशन के लिए हमने y को वेक्टर बना दिया. ठीक है. And now the multinomial logistic regression, we will not learn one model. We will now learn k models. So k models are learned, one for each class. And I'll write the z case here. So zk हमारे पास क्या था? So w k dot product with x plus b k. ठीक है. And this is k is equal to 1 to capital K. So we have k such functions. W, this in this case I've written this in vector notation. So this is also a vector. B is still a scalar. ठीक है. So for multinomial, you are now going to learn k such functions. ठीक है. और of course ये मैंने so basically ये मैंने so y probability of y k given x is now of course sigmoid sig of zk. ठीक है. And again k is equal to 1 to k. So k such functions हैं. So y underline k prime, वही हम notation use कर रहे हैं. So the output now is the probability for the kth class. ठीक है. So probability for the kth class is given by this. ठीक है. Actually ना थोड़ा सा इसको softmax use करना, तो वो मैंने नहीं किया. So just hold on. We actually use the softmax here, not the sigmoid function. So for multi-class classification problem, we do not use the sigmoid. Remember, sigmoid gives you a value between 0 1 for a single uh, z. Here we are using sigmoid for all the z's. So here we are using softmax for all the z. ठीक है. So in other words, जो मेरे पास y k prime for the kth value would essentially be the softmax function of all the z's सारे z देने पड़ेंगे मुझे, 1 z k, and this is written as exp of z k divided by the summation for all k's of exp zk. ठीक है? So actually this function is normalizing the exponential. So exponential of z is the output of the function zk, and then we are dividing with the sum of all the exponentials, meaning that k हम normalize कर रहे हैं to 1. So that's why yk prime would be a value between 0 and 1. So for multinomial classification, we use the softmax function over all the outputs. So remember, इसमें सारे output denominator पे चाहिए आपको, z1, z2, z3, zk, सारे चाहिए to get the output of z small k. Okay, let me see. You are right. So that you are right. So I wrote x there. So this is z, the output of the linear model for each of those k classes. So output को एक्सपोनेंशियल से पास करना है, और जिसकी आउटपुट चाहिए उसको फिर हम सारे सम ऑफ द एक्सपोनेंशियल्स से हम डिवाइड कर देंगे, सो दैट वी गेट ए वैल्यू बिटवीन 0 and 1. सो दिस इज कॉल्ड द सॉफ्ट मैक्स फंक्शन. तो मल्टीप्लास क्लासिफिकेशन के लिए हम सॉफ्ट मैक्स फंक्शन यूज करेंगे, और बाइनरी क्लासिफिकेशन के लिए विल यूज द सिग्मॉइड. बट एज लेटर ऑन एज वी विल सी, न्यूरल नेटवर्क्स में, इन न्यूरल नेटवर्क जनरली वी वी यूज द सॉफ्ट मैक्स even for binary. So gk is basically the output of the kth model. Why is that an issue? So we saw it here. So this is the zk here, the scalar output for a single class k. It has its own parameters wk and bk for a given x. But the output of the model, since we want probabilities, we will pass it through the softmax so that the y prime k, prime just meaning that this is the output, uh, to distinguish it from yk of the actual data. Okay? So whenever you have a softmax for a set of values, obviously the max probability would give you the class. ठीक है? So let's say again वो 5 वाली मैंने एग्जांपल ऊपर दी थी. ठीक है? So let's say अब मेरे पास y प्राइम है. y प्राइम का वेक्टर मैं लिखता हूँ, let's say. Remember now this is going to be normalized that sums to 1. So 0.2, 0.1, 0.4, ये हो गया 3 हो गए, 4, 5, 6, 7, 0.2 and 0.1. ठीक है? So let's say this is the output that you get from y prime from by taking the softmax of all the zk's. Okay. So in this case, what would be the class? The value that has the highest probability. Okay. So this is the at the third position. So it means that best class is 3. It has the highest probability. Okay. So our prediction is saying that this is class 3. Sure. Okay. Any other question? Okay. So we are going a bit slower. I wanted to complete neural networks as well. 15 मिनट रह गए. Okay, I'll just again wait a few seconds. So any questions, try to internalize this. I know this is a lot of notations here, but it's fairly easy and it's fairly repetitive in the sense that you might have studied this before and you'll definitely study it later on as well. तो ये जो फंडामेंटल चीजें हैं ये आपने सॉलिडिफाई करनी है अपनी. So don't think of this as repetition. Think of this as something that will be helpful later on for you as well. All right. There are no questions. So let's move on to neural networks. By the way, the learning for, so what are the parameters that we want to learn for multinomial? So we want to learn all the WKs and we have to learn all the BKs. So K is equal to 1 to K. So now the set of parameters is much larger. And of course, we will learn it by defining a loss function. So usually this is, I won't go into the detail, but this is usually called the multinomial cross entropy. उसी तरह का है जिससे हमने पहले बाइनरी क्रॉस एंट्रोपी का फंक्शन लिखा था, बिल्कुल उसी तरह का ये जस्ट दैट नोटेशंस अब विद y एज ए वेक्टर यूज होगा. और जो y, बाय द वे इट्स क्वाइट एक्चुअली इजी बिकॉज आपके एक्चुअल डेटा सेट में सारे y 0 हैं, सिर्फ एक y 1 है. जो y 1 वाला है उसी की हमने लॉस निकालनी है, उसकी आगे प्रोबेबिलिटी लगानी है, सम इट फॉर ऑल द डेटा सेट, तो वो आपका लॉस होगा. तो बाकी ऑब्वियसली सारे जीरो हैं, वो जीरो किसी प्रोबेबिलिटी से मल्टीप्लाई होगा, जीरो हो जाएगा, लॉस में आएगा ही नहीं. ठीक है. इसको मल्टीनोमियल क्रॉस एंट्रोपी कहते हैं या मल्टी क्लास क्रॉस एंट्रोपी भी कहते हैं, एंड दे माइट बी सम अदर नेम्स एज वेल. बाय द वे ये जो मल्टी क्लास मल्टीनोमियल लॉजिस्टिक रिग्रेशन है, इन ओल्डर पेपर्स about 20 years and older, yeah, 15 years and older, you might see it being called maximum entropy classification, yeah, classifier. So this is same as multinomial logistic regression. It's the same thing, but nowadays hardly anyone uses maximum entropy classifier. Most people use the logistic regression name. Okay, so now let's start neural networks. And most of the notations would be similar to what we have already studied in logistic regression. And you will appreciate why we studied logistic regression, because neural networks are simply, you can say, supercharged logistic regression models or multiple logistic regression models. Okay? So of course, neural networks were initially inspired by human neurons and their interactions. But nowadays, we focus simply on a computational unit as key building block of NN. And that computational unit is simply your logistic regression. So what is that computational unit? So the output Z of the unit is simply Y X plus B. ठीक है, ये क्या था? ये लॉजिस्टिक रिग्रेशन था हमारे पास. W and X, of course, are vectors, and B is a scalar. And we have taken the inner product or dot product between them. So this single unit does this computation with an activation function. अभी तो ये linear था, ठीक है? So now the output of this single neuron now would be, ठीक है? So A some activation function of Z. So this is the computation. Single neural unit कर लें. ठीक है? तो ये वाला फॉर्मूला आपने देखा हुआ है. G की जगह आप सिग्मॉइड डाल दें, A की जगह आप Y प्राइम डाल दें. So this is exactly your logistic regression model. ठीक है? A हम यूजली इसलिए यूज कर रहे हैं, दिस इज द एक्टिवेशन ऑफ द न्यूरॉन. तो A हम so A is activation. Z is the aggregated summation which is given by the linear model, where we multiply each input with a weight. Yes, there could be other activation functions. We'll discuss that. So G would be sigmoid at the last layer of a neural network if you are doing classification, binary classification. G would be softmax if we are doing multinomial classification or multi-class classification. Inside the neural network, as we will see later on, usually G would be tangent hyperbolic or more recently the rectified linear unit. वो हम अभी देखते हैं shortly. But G should be a non-linear function. ठीक है? So this is essential for neural networks. ठीक है? So this is essential for neural networks. And we have seen two functions already, softmax as well as sigmoid or logistic function. Both of them are nonlinear. And in this particular case, both of them are also continuously differentiable. ठीक है? Time थोड़ा रह गया, so let me move forward. What should I cover first? Okay, so a neural network has now multiple layers. So maybe I can show you some slides. Yeah, maybe I can do that next time. So let me write the notations first. Okay. All right. So we have our input X. Input is X, right? And we have our output Y. ठीक है? ये हमारा problem definition है. Input X generally is a vector. Y would be a vector if it is a multi-class classification problem. ठीक है? So neural network, and we are talking about feed-forward neural network. Information flows from X to Y in one direction only, without any flow of information back from a later layer to a previous layer. Okay? So info flows from input to output through multiple layers in general. ठीक है, of processing. ठीक है. So generally, if I want to write, so we have an input layer. ठीक है, लेफ्ट से राइट या बॉटम से अप जनरली ड्राइंग में लोग शो करते हैं. ठीक है, सो इनपुट लेयर होगी. देन इंटरमीडिएटली यू कैन डायरेक्टली हैव एन आउटपुट लेयर. ठीक है, without an intermediate. So this essentially, so this is your logistic regression. ठीक है, इनपुट और आउटपुट, वो जो ऊपर इक्वेशन लिखी थी वो सिंगल न्यूरॉन की थी. सो इफ यू जस्ट हैव एन इनपुट लेयर में जनरली एक्स होता है हमारे पास. देयर इज एनी कंपटीशन ओनली अकर्स after the input layer. And if after the input layer you have directly the output layer, you have simply what is known as logistic regression. ठीक है, otherwise input layer आपके पास है, then one or more hidden layers इनको कहते हैं हम, and then output layer. ठीक है, so this is our multi-layer feed-forward neural network. ठीक है, so while referring to the size of a neural network, we do not count the input layer, because input layer में कोई प्रोसेसिंग नहीं हो रही, just input x, कोई प्रोसेसिंग नहीं होती. प्रोसेसिंग सारी later layers में होती है. So that's why the size of neural network does not include input layer. So let's say if you have a input, hidden layer 1, hidden layer 2, and then output. So how many? This is called a 3-layer neural network. ठीक है, so there are 2 hidden layers, there is an output layer, so this is a 3-layer. Input layer को हम count नहीं कर रहे. Similarly, जैसे input and direct output, this is a 1-layer neural network, which is also a logistic regression. ठीक है, I hope this is clear. And then in the next class, I think I'll stop here. In the next class, we will go through flow of the information from input to output layer, and it will be almost identical, or I will say identical to logistic regression, multiple logistic regressions. सिर्फ notations का थोड़ा सा issue आएगा. Notation मैं कोशिश करूँगा consistent बनाऊँ and follow the textbook, and that would be it. I think it will not take more than 15 minutes. हमने इसकी learning discuss नहीं करनी. So back propagation, we are not going to the discussion of back propagation, because that is something that you probably have studied elsewhere, and it's not directly used in this course. But obviously, for those who want to refresh their machine learning and AI, they should do it repeatedly, because back propagation भूल जाता है लोगों को. ठीक है, and then we will move on to word to vec, which is dense embeddings. ठीक है, and of course in next class हमारा quiz B है. So any questions? Yes, back propagation is the adjustment of weights in a neural network or parameters in a neural network using derivatives. So actually, we can use partial derivatives in logistic regression as well, or derivatives in logistic regression. वही चीज है, but since it is back prop, yes, we do have a quiz in next class. Back propagation for IR, You can use the notes that I used in class, वो मैंने पोस्ट कर दिए हैं. You want me to write that in a proper way? And because उसमें मैंने पूरा एग्जांपल की थी लास्ट लेक्चर में. द IR इवेल्युएशन मैंने लास्ट लेक्चर में इन क्लास की थी, एंड आई एक दो टाइपोस थे मैंने ठीक करके अपलोड कर दी हुई है. यस. So this quiz would cover all contents from the last quiz till today. ठीक है. So this will include, all right, the chapters from the book are chapter 11, section 11.1, and this is the complete section 11.1. So let me write it here maybe. So 11.1, so this is completely done. Uh, पिछला क्विज था हमारा, उससे बीच में हमने कुछ कवर किया था. पिछले क्विज में हम क्या किया था, फॉरगॉटन. वी वेंट अप टू मिनिमम एडिट डिस्टेंस. अच्छा, ठीक है. ठीक है, तो 11.1 हो गया. एंड देन लॉजिस्टिक. चलो मैं पर कोशिश करता हूँ आज या कल वो अपलोड कर दूंगा IR का. लॉजिस्टिक रिग्रेशन इज चैप्टर 4, एंड एक्चुअली इट इज ऑलमोस्ट अ कंप्लीट चैप्टर. बट ये कि ये थोड़ा सा आपने क्विक पढ़ना है, एंड वी हैव कवर्ड मोस्ट ऑफ इट. तो इसमें लर्निंग वाला पार्ट है वो आप स्किप करेंगे. स्किप द लर्निंग. ठीक है. And also we have not covered some aspects like evaluation of text classification and harms from text classification. वो अगली क्लास में पढ़ेंगे, तो obviously वो नहीं होगा. So the part on logistic regression without details on learning वो हमने chapter 4 से लिया है. Neural networks with chapter 6, बट वो हमने बेसिकली स्टार्ट ही किया. मेरा नहीं ख्याल वो पढ़ने की ज़रूरत है. जो मैंने इस लेक्चर में किया है वही सफिशिएंट है. And then after chapter 6 we come back to chapter 5. So I'm afraid थोड़ा बहुत हम ऊपर नीचे jump कर रहे हैं, because I feel this is a better progression for you guys than following the progression that is given in the books. Yes. So gradient descent का जो basic formula है वो आपने पता होना चाहिए आपको. But I would not ask you to run a gradient descent uh, step by step in your quiz. Formula पता होना चाहिए आपको. उसका ड्राई रन जरूरी नहीं है. That would typically be done in a machine learning course. ठीक है, तो